Welcome, sir. Good evening.
Very good evening, sir.
Very good evening. Good evening, everyone. So let's continue the session for today.
Thank you, sir.
Okay. So let me share my screen with you first. Good evening, Darshana. Good evening. Let's continue the today's session. Yesterday we have covered few part of the data visualizations with our basics. We have covered this. Hmm, we are doing this one box plot we were making. Yesterday we have created this box plot. I will show you.
Yes, sir.
Okay, and here we see one function I would like to explain you that the t apply function we use sometimes. Okay, there is no uh, t apply function. The empty cars mileage is a continuous variable, and the cylinder is a categorical variable we are using. And the number of cylinder 4, 6, and 8, and then we see the summary. If I use the summary function, I will get the summary of the all that category. The 4-cylinder summary is the 21.4 is the minimum mileage, and the 22.80 is the first quartile of the mileage, then the median, then the mean, third quartile, the maximum. As per the it is split the mileage in three categories like the 4-cylinder, 6-cylinder, and the 8-cylinder. So t apply function I will explain you later on about this. Here we are taking one object name E for the t apply functions mileage, empty cars mileage, and the cylinder, and we are finding out the mean only. And I will show you this. So you will see in this way we are getting the mean of 4-cylinder is vehicle mean of mileage of the 4-cylinder is 26.66. Mean of mileage of 6-cylinder vehicle is 19.74, and mean of mileage of 8-cylinder vehicle is 15.10. So you know that the cylinder increases, the mileage decreases, and we create one bar plot for this. So you see we are getting in this way the bar plot. Yes, yes. Now we are making a mileage and cylinder box plot. That is a notch we are taking. The notch is true, so we will get the plot in this way if we use the notch. If you don't use the notch, then you will get the simple box plot in this way. So that is nothing. That is the simple box plot we are getting. We are taking the mileage and cylinder on the x-axis, the mileage on the y-axis we are taking it. Yesterday I explained this thing. And now we see the histogram, how we create a histogram on uh, with our basics. So we have the attributes, the VV is a vector, the data, whatever the data we have. Main is the title, X level, X limit, Y limit, black, breaks, and the color and the border. So we'll see one by one. So I'm making a vector here that I am writing the X lab weight and the color is yellow, border is blue, break 3. So I will show you this. So I'm getting in this way. Okay. So if you don't write the break, then see what happens. Okay. We are getting in this way. Okay. So there is in this interval, there is no uh, frequency, there is no data point. So we could reduce the break. So I'm taking 3 breaks. So it will adjust the break like that. It will not as per the quantity, the 3 breaks. So it is the more than 3 breaks, 1, 2, 3, 4 breaks. So it will cover in the 4 breaks as per the data. If there is a rational, irrational number, we are getting a number, non-terminating rational number we are getting in the interval. then it will change its break in the nearest one. So there are the 1, 2, 3, 4. We have mentioned 3. If I mention 4, see what happens. We will get the same thing. Understand? Why we are not getting the 3 breaks? If we divide the 50 by 3, 3 breaks if you get here, 1, 2, 3, and then you will see how we will get it. Okay. So we get some rational number which is non-terminating. So that is the one. That's why you could use the 5 break. So in the 5 break we are getting in the default. So why it would be better to take the 4 breaks, so that it is giving us the 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Okay.
So, sir, if I want, sir, 5 classes, okay,
Okay.
5 classes, then how will we do it? Even 5, 4, say 7, 8, 9 classes. But
We are getting in this way.
no, here 1, 2, 3, 4, 5, 6, 7, 8 classes, right, sir?
8.
8, yes, sir. 8 bars, and one is empty bar.
It will not give that much. 1, 2, 3, 4, 5, 6, 7, 8. We are getting the 8 bars.
Okay.
If you write the 7, you see, we'll get the same. 6, same. 5, same. Then you write the 4.
Sir, if I only want 2 bars. Oh,
How many?
2 bars. 2 classes in a histogram. 2 class interval means 0 to 25, 25 to 50.
Will not get it. Because in the 2, 0 to 20, 20 to 40, and 40 to 60 we are getting. Yeah. I will tell you, we could increase the limit or decrease the limit if you want that. So in that way, X limit and Y limit, you could change the limit. Okay. 0 to 30 and 30 to 60 you want 2. So 2 class we will not get over there. No? Okay. So this is a histogram we just make in the R basic for our understanding. Suppose you know that the data of empty cars. You know the data of empty cars? Yes. How many are aware about the data of empty cars data? Yes. Who is not aware, please you write no. So I could explain that data to you, then we explain something about it, why we use this R basics diagram. Yes. Tarsan don't know. Akshay don't know. Other one? There are 16 participants. No. Glenn don't know. Yes. Other? Only 3 had responded here. Fahad don't know. Okay. Okay. Most of you don't know about the empty cast data. So I explain you the empty cast data. Just wait. So what is empty cast data? So I am taking that data in my environment. I remove everything from here. There are so many data sets in R and in default. And there are so many data in the different libraries also. The packages we install, there are some data sets for the practice. So if you want to know how many datas are there in the R default for practice purpose, so you could write the data and just keep the blank parenthesis and just control enter. You will get the list of the data sets. So these are the data sets in packages data sets. It is the default air passengers, BJ cells, and BOD, CO2, DNS. So this sort of data we are getting. So many data sets we are getting here. Getting? These are all data sets. Okay. So one of the data set I am taking from here, that is the empty cars. This data set I am selecting. Okay. It's a small data set and it is very good for the understanding the analysis. There are many you could do with so many data sets. Okay. So we are using the empty cars. So I just show you. So I give some name to that data set when I read here. So empty cars and I run it. So you see, I have got here 32 observations and 11 variables. If I click here, I will get the view of this data frame. That is the mileage, cylinder, displacement, horsepower, draught, weight, cubic, VS, AM, gear, and car. So I will explain what does it mean, MPG and these all. These are the name of the models of the cars. And if you want to know more about these data sets, which are in default, just put a question mark, then write the empty cars and run it. You see here, it is a motor train car road test. The data was extracted from 1974 Motor Trend US magazine and comprises fuel consumption and the 10 aspects of automobile design and performance for 32 automobiles. So there are 11 aspects totally. One is the fuel consumption, 10 other aspects. So we see here the 32 observation and the 11 numeric variables. All the variables are numeric. Mileage, cylinder, so mileage is the miles per gallon. Okay. Cylinder is number of cylinders. Displacement, cubic inch of the piston. Horsepower, gross horsepower of the car. Draught, the rear axle ratio. Weight in the 1,000 pounds. So it is the weight. And the cubic is 1/4 mile time. And VS is the type of engine. Vertical V-shaped engine and straight engine. So 0 for the V and 1 for the S. Got it? Whenever we make a binary column, 0 in one form. Suppose you have a gender. You have a gender column. In gender, you have two categories, male and female. And now you want to convert this in binary form, 0 and 1. Suppose the male you are making 1, the female you are making 0. So then you have to write the name FM. So 0, 1, 1, 0, if you see, so you could understand that the female is 0 and the male is 1. Got it? So in this way, here also we are writing the VS, V for 0 and S for state. V for 0, V saved for 0 and in this way. Got it? So this is a way to give the binary. AM is the gear transmission. The gear transmission may be the automatic or the manual. A for automatic and the M for manual. Got it? Any doubt? So number of forward gears, because the reverse gear is always 1 in a car. So number of forward gears they have given. The carburetor, number of carburetors they have given. Okay. Akshay, not clear? Clear, sir. Okay. So these are the variables. You will get the details of the data here. Sorry. I just remove this and cut it. Then I will make it 3. So You got what is this data? And whenever we read some data, we see the structure of the data first. You know that. So we get this structure here. We could read here through the command in the console, or we could read here also. Just click here, you will get the structure. The mileage is a numeric, cylinder is a numeric, all the variables are the numeric class. Okay, now the sum we could convert in a categorical form, this we could convert in categorical form, this we could convert in categorical form, we saved in the state. Okay, gear we could convert in a discrete format in the factor form. But I will just explain you why we use this. Okay, so why we use the visualization of the R basics. We prepare the visualization in a ggplot, and the interactive visualization, that is the very impressive. But here in the R basics, we prepare the visualizations for our understanding. So I will show you the histogram I am making just for the MD is the data set. And if I put the dollar, then I will get the drop down menu of the variables. So I am using the mileage. I will see it is a continuous variable, and I see how does it look like. You see it is a skewness. You could judge from it. Can somebody tell me whether this data is normal or the skewed positive or the negative? Yes,
Right, positive skewed.
positive skewed, correct. So it is a positive skewed data. So for this purpose, we use this R basic for our understanding. You could use the box plot also. So there is no outliers here in this data, or it is positive skewed. It also shows because the lower whisker is smaller than the upper whisker, so it is the positive skew. Got it? So this sort of graphical presentation we do for ourselves, not for the client or for the presentation, for understanding the data for ourselves. You know? Similarly, if you want to see the histogram of our MD dollar, other continuous variable, that is, this is this way. Okay, and we could see the box plot of this MD dollar. That is the box plot. Okay. Similarly, you see the histogram of MD dollar. Horsepower is also a continuous one. It is also positive skew. So you could see this whole thing here. And the visualization, this visualization we use for our understanding, because there is a small command. You just have to write down the hist, and you have to put down the data inside that, and you will get the graph, everything. Okay, so that is why we don't use this basic visualization for the presentation purpose. Okay, I have given these all things, but that is not good for the presentation. It will not give you the very impressive figures. Okay, so you see this. I have developed this vector, and then I am using that vector, and the X label is the weight. Y label is the frequency in default in the histogram, and the color is green, the border is red, and the X limit is 0 to 50. Y limit is 0 to 5. Okay, and the break is 3. So there is no 3 breaks. 1, 2, 3, 4. Okay, so if I make a 4 break, it will still the same, because the 4 break it is taking from 50. If I make a 3 break,
Sir, why it is not taking 4 breaks?
3
If
breaks,
we-
why it is not taking? So you divide 50 by 3, you see what you get. What are you getting? Non-terminating rational number.
Right.
It will continue 16.666666. Okay,
Yes, sir.
what the reason why we are not getting that 3?
Okay, sir.
If you write here the limit 60 instead of 50, Okay. Now you could make it. But we have a data up to 50 now. Then we are not getting here any frequency.
But sir, here
We are not getting any frequency there. It is not dividing by this. Okay.
yes, sir. So, but sir, here 1, 2, 3, 4, 5, 6 breaks, not 3 breaks.
1, 2, 3, 4.
5 and 6.
Inside. No, this will not the break.
Okay. Inside, yes, sir.
Inside. 1, 2, 3, 4. Okay. In this limit is only it will print here. It will not divide the data in that way. Okay. It will not divide the data. So if you write any limit, if you write the 70 also, you will get the 70. But you will not divide this data in that way. If I divide in 5, you see, I will get the data under that, whatever the values we have. We have the maximum value is 41. So it is the under 50. It is not more than 50. So I am using the limit 50. If I don't use the limit, zero to 50 I am taking. And here I take the 3. Sorry. It is okay now. Okay. It's clear why we are not taking the 3. We are taking the 1, 2, 3, 4. Because if we divide by the 50 by, you could not get that. Okay. And the line graphs, if you see, so I will show you the line graph. There is a vector I have created. Then I will plot the line graph. I will use the V only, plot V. Then what I will get? I will not use this one. I will just plot V. What I am getting here? These are the index I will get automatically. These are the values of the vector. 7, 12, 28, 3 and 41. This is the 7. Height is 12. Height is 21. 28, sorry. This is 3 and this is 41. And this is the indexing of the first element, second, third, fourth, fifth. Automatically default, you will get the index on the x-axis and the values on the y-axis. Okay. But it is a scatter plot basically. If I do it, if I write the type 0, type B, we have 2 types. So I will show you that. You see what I am getting here. Line graph. Got it? Or if I use instead of 0, B, then I see, you see the difference in both. You see the difference in the previous one and this one. What difference you are getting here? The line is breaking near the data points. Okay. I will explain you some more things later on. We could have different sort of lines. Okay. And here I am taking the type 0 and color rate, X label month, Y label rainfall, and the main. So I will get these all things here, and the color is red now.
Sir,
Okay.
I have a question.
Yes.
Sir, if I don't know how many types, you say there are 2 types, okay? O and G.
Yes.
Same,
Yes.
there are many colors, red, blue, brown, black.
Mhm.
But sir,
Mhm.
is there any list of the colors we can see
Okay,
by the command?
I will show you by the command also. Okay, I will show you everything. It is here in the script. Okay, when we see the graphical parameters, then I will show you
Okay, sir.
everything. So empty cars mileage type B, if I produce, so I will get in this way. There are 32 observations. We know the empty cars data. Okay, and here I am making a multiple lines in a graph. So I have taken the three variables, three vectors I have created here. This is all three, and I plot with the first vector V and the type B, color rate, and this all I am giving. And the second line, if I want to create on this graph, then I just have to use the lines. I don't have to use the plot lines. And the vector name, the second vector I am using the U, type 0. Here I have used the B. Here I am using the 0, and the color is blue. So you will see second line. This is the third line. Got it? So we could create a multiple lines in a plot also. Okay.
Means first we have to use plot, then
Ah,
we are making more lines in same graph.
same
Then
graph.
then we will use lines, then
Hmm.
another lines function, then
Yes.
another line function.
Okay.
Yes, sir.
Then we see the syntax for the plot. For this plot syntax I have given you. We are taking only the one variable. Now if we take the two variable instead of one in a plot function. So I am taking the here empty cars MD. I am taking the MD. You know that the empty cars we have given the MD name. And here also I am using the MD.
Yes, sir.
So I am taking the weight of the car on the x-axis and the mileage on the y-axis. And we know that if the weight is increasing, the mileage will decrease. Everybody knows it. Got it?
Yes, sir.
So we see this graph here, and the x label I am writing the weight, and the y label name I am giving the mileage and the x limit. So this I am just hiding at this moment. Okay, these two things I don't want to write. It should be in the default. It will take from the and I run it. You see, as the weight is increasing, mileage is decreasing. Okay, so it is from 0 to we have the all weight from here. The it is in the 1,000 pounds. It is the weight of the car, and this is the mileage of the car. And if I use this here x limit, I just use the x limit first. You will get, I am getting the, I have increased that I am using the limit from 2.5 to 5.
Sir,
2.
can we use here type?
Type, yes, we
Yes,
could
sir.
use your
Type
type.
OB.
No, the type is for the line.
Okay.
We could use this, we could change this thing. We could use the triangle here, we could use the field circle point. We could use different geometries here instead of this blank circle. Understand? So I will explain you that all later on. It will come. I run this, you will see.
No, sir. I'm asking if I want to join in previous graph we see some continuous line from this point to this point from this
Mhm.
in type O and type B, then there is separation around circle, right? Sir,
No,
if
it is a scatter plot basically, and we could do that with the scatter also, but it will be very zigzag. Getting it?
yes, sir.
It will be very zigzag. As
But
I
sir, I just want type O type O geometry
Hmm.
corresponding to weight variable, not mileage variable, right?
Hmm.
Here, here both combined, right?
Hmm.
But I just want line corresponding to weight variable.
Then you don't use the mileage as a variable.
Okay, sir, got it. Actually, this is a scatter plot. So first
Oh,
plot, then second, then third, and fourth.
yes. Okay.
Yes, yes, sir.
If I just plot in this way, for our understanding, we are getting in this way. We have not taken this all non-data link. And for the horsepower and the weight, I could take in this way. The horsepower increases, weight also increases of the vehicle. Now we see some Pierce plot. And a Pierce plot, we see there is a formula, then data. So this is the formula. There is no dependent variable because it is the correlation plot basically. So this is a tilde we will start and we will write down the variables, weight plus mileage plus discipline. Whenever we use the tilde, we will use the plus. We will not use the comma. Understand? Here everywhere we were using the comma, but here we have started with the tilde. This pair function starts with the tilde. Whenever you use the tilde somewhere, then you will use the other variable. If you including the more variable, after that, then you add on plus sign you will use instead of comma. That is very important thing. And then the data is empty cars and the main is the name of the plot I am writing here. Yeah, then you could see it. So I will just make I will increase the size of this, then it would be better view. I just look at this now. This is the mileage and weight. So the weight on the y-axis and mileage on the x-axis. As the mileage increases, weight decreases. Mileage increases, weight decreases. The same thing. Here it is the transpose of that. Here in the x-axis is the weight and the y-axis is the mileage. So as the weight increases, mileage decreases. Got it? Yes. Here you see the weight and displacement. So weight on the y-axis and the displacement on the x-axis. As the displacement increases, the weight also increases. Here you see the cylinder and the weight. So cylinder on the x-axis and the weight on the y-axis. So in the 4-cylinder, you see the my weight is low and the 6-cylinder weight is medium and the 8-cylinder weight is higher. Got it? Does that make sense to everyone?
Yes, sir.
And now I will explain you the graphical parameters. Okay. So now you will, whatever the queries you had will be solved here in this part. Graphical parameter, it is a very big topic. You see, it is the, we have covered only up to here, and here we will read only for the graphical parameters. It's a very big script. You can customize many features of your graph, fonts, colors, axes, titles through graphic options. And one way is to specify these options in through the PAR parameter function. And parameter function. If you set parameter values here, the changes will be in effect for the rest of the session. Okay. For until you change them again. And if you set this parameter, then it will affect all the subsequent chart, whatever you are going to produce after that, until you change it. And it will apply on the all uh, subsequent charts what you are making after running this parameter. The format is the parameter, the option name is equal to value. Option name is equal to value in this way. So set a graphical parameter, PAR. So we are using the PAR view current settings. If you want to see the current setting, just you write the PAR and the blank parentheses, and then you will see the current settings. So there are so many things. These are the parameters we have. So many that I will show you how to combine the different. This is the automatic. This is the pairs. If you make it is a scatter plot matrix you will get here. The other sort of plot I will explain you how to combine them. Okay. X log false, Y log false, adjust, adjustment is 0.5, N is true, ask is false, background is white, uh, B type is 0, and the CX, it is the size of the your anything, you know, whatever the geometry you are using, their size and the font size data. CX axis is 1 is a CX axis is 1 is this one, 2, 3, 4. CX man is 1.2, man is 1.2 here, and the CX sub is 1, the sub will be 1 on the, and the CIN. So I will tell you one by one when we work it graph. The main thing I will explain you just here. This is the margin, that is very important. Margin is what? If you create any graph here, I will show you in this graph. So it is the 5.1 margin on the bottom. It is 4.1 on the left side. You see it is the smaller than this. Here you are getting the 4.1 again. And you are getting 2.1. This margin and this margin is same. This margin is highest, this margin is the lowest. It is the default parameter. Okay.
Yes, sir.
So I will tell you one by one. There are so many parameters you could not understand directly if I explain here. We will do with the practical and I will explain you. So make a copy of current settings. Whenever you make a setting, then you make a copy of the current setting, and you could write any name. I have given here the O parameter, O for the original parameter. I am saving this original parameter what I have. So this is the current settings. I have default. I have set it. So because I will apply again this now. Now what I am doing, I am making I am giving the parameter color dot label. Label color I want red. Label is this. Okay, these are the labels. In default, you see these are black. I am changing the parameter. And then I make a histogram of the mileage. Look at this. Getting it? If I make a bar plot of MD dollar displacement. No, not the bar plot, the box plot I was going to make. There are no label, but in the histogram there is a label. So I will use the histogram for the next one. You see, you are getting the rate. Whatever the figure you will create here, you will get the rate labels. Okay, because you have set this parameter until you change it. Now I want the original parameter. So original parameter is OPAR. So I will write in the parameter. This is the original parameter dimension, which is the 5.1, 4.1, 4.1, 2.1. So that will restore, because if I show you at this moment what are the parameter. So these are that is the default size only. But if I show you the parameter, so the previously what I will show you that color also. There are so many things to search it out, very difficult. The color code is there. black. Color subtitle color is black. Main title color is black. Label color is black in default. है ना? Label color. This is red now, but in the previously we have seen that. So if I again run this parameter, so I will see what is the current parameter. You will
Sir,
get
if
there.
sir, if we want to change a font or in italic or
We could do everything. We could do everything. We could do everything. I will explain you one by one. You see, color label red. At present, whatever the parameter we have changed, so it is red. Now I am converting again with the same default parameter. So we will get again that black. And the second way to specify graphical parameters for a particular graph, you don't want to apply on the subsequent graphs. So you could write this color label green here or the red, whatever you want. So I'm changing this color label. When I just make a graph with this now, so I will get the black because I have changed the default parameter. Now I am changing the parameter only for this histogram. I want here the green. You will see. I will get the green one. Okay, color dot lab I will write in that function and I could use it. Understand? Text and symbol size. What you were asking to me. Text and symbol size. We have a very long. Okay, I will just do it. So get it. Text and symbol size. The following options can be used to control text and symbol size in graphs. Option description CX 6 number indicating the amount by which plotting text and symbols should be. Okay, scale relative to default. 1 is equal to default, 1.5 is 50% larger, 0.5 is 50% smaller, etc. What it?
okay.
CX.
Yes, sir. Yes, sir.
CX axis, magnification of the axis, annotation relative to CX. CX label, magnification of the X and Y labels relative to CX. Okay. CX man, magnification of the titles relative to CX. You could increase this instead of it is 1 in default, you could write the 1.5, it will increase the size of this. CX sub, magnification of subtitles will always be in the bottom. So that is the main text and symbol size. What it? So I will do here something. I will use the CX and dot lab I will use. Okay. And I will use it 1.5 instead of 1. We see. Have you got the difference?
Yes, sir.
In the label, if I want 0.5 only, main, CX dot main. Sorry. Dot equal to 0.5 if I write, you see in the title. It is, you could take any number, not the 0.5, you could take the 0.8, 0.9, move 1.2, 1.2 you take, that is 1.2 and we will remove it. You will see it will increase in this way. Got it? 1 is default. So this is the way. And the font type, I will show you how to change the font type later on. Now the plotting symbols. Plotting symbol is the PCH we will use for the plotting symbols. Option to specify symbols to use when plotting points. And the point underscore PCH. For I will show you this figure. These are the PCH. If you take the PCH 0, then you will get the square. If you get the PCH 1, you will get this hollow circle. If you get PCH 2, then you will get the triangle. So I will show you. that. I will show you here.
That picture is in R itself, or we have to download from another source.
I have downloaded it from some other source.
Can we not find from the command or by the help function PCH using?
We could find it with the help function also. We could find, but not in that way. Okay, I have written here, no? That's why you will see here. You will get in this way.
Okay, yes, sir. Got it.
Okay, you will get the every detail here. Just put the question mark and then write the attribute whatever you want. Okay.
Yes, sir.
So the PCH you see, I have explained you what does it mean. For the symbol 21 to 25, specify border colors and the fill color background. And a fill color background if you want to fill, and the border color you will get the color. If you write the color, then it is a border color. Okay, just around the border, it will color the border. If you write the BG, then it will fill the background. You can change lines using the following option. This is particularly useful for reference lines axis, fit lines. So the lines type I will show you. One is for line type LTY. One is for the complete line without any break. Second is the dash line. Third is the dots line. Fourth is the dash dot line. Then there is a dash line, big dash, and then there is a small and then the large and small, both sort of dash. 1 to 6. Got it? LTY. And LTY line type, see the chart. I have shown you the chart. The LWD is the width of the line. Relative, the default is 1, and 2 is the twice the width wide of that. So you could do that. LWD is the width. LTY is the line type. Colors. So I will show you the color chart I have shown you, but I will explain you some more thing here. The color default plotting color scheme function accept a vector or values that are recycled. The color dot axis, you could change the color of the axis, you could change the color of the label, you could change the color of the title, you could change the color of the subtitle. Figure plot foreground color, axis, boxes, also set color to same. BG background, foreground color and the background color. And FG and BG, foreground and background color. And you can specify color in R by index name, hexadecimal and RGB. For example, color is equal to 1, is color is equal to white, color is equal to this is R equivalent. So you could search on the internet the color R color scheme on the different RBG format. You will see hexadecimal, you will see by name. You could get here. You can also create a vector of n contiguous colors using the function rainbow n and the heat colors n, the Terrian colors n, whatever the color, the 5 colors, 6 colors palette you required, and topo colors n, cm dot colors n. And n means any number, how many colors you require in that palette. Colors written all available colors name. Okay, so I will show you this. I will just look at this. These are the color names. You could write any color name.
They are in thousands, sir.
Yes. Okay. We have these color names. Now the fonts, you can easily set font size and the style, and a font style and the size. But Font family is a bit more complicated. So I will explain you the font family also here. Uh, Option description, the font integer specified font to use for the text. The one for the plain text, two for the bold text, three for the italic, four for the bold italic, and five for the symbol, whatever the symbol you have. Okay. So font equal to one if you write, then you will get the plain. Font dot axis, font for axis annotation. Font dot lab, font for the x and y labels. Font main, font for the titles and the font sub, and this way. PS font size is for the PS, the roughly 1 by 72 inch. Text size PS dot CX. Okay. So family font for drawing text, standard values are the serif, sans, mono, symbol, mapping is device dependent. In Windows, mono is mapped to text Courier new, and the serif is mapped TT times new, and the Roman series sans is mapped to TT Arial in this way. I will just show you few things. So I'm making a plot. On the x-axis, I am taking 10 by 10, y-axis, I am taking 10 by 10. And I just keep this later on. So I will just show you first this one. You see, I am getting this plot. Am I right? 1 to 10 I have taken here, 1 to 10 I have taken there, and 1 to 1, then it is 1 1, it is whatever 2 2, 3 3, 4 4, 5 5, 6 6, 7 7, 8 8, 9 9, 10 10. Got it? Any doubt?
No, sir.
But I don't want this dots here. I don't want any geometry here. Then what I will do? I will write the type equal to n, not 0 or b. What I will write the n for, and I run this, you will see the, what is there? What are you getting there? There is nothing now. Okay? There is nothing. Now, I will make a text here and giving some location. And giving some location 3 3. 3 3 Cypher Analytica default. So I will show you. So it is the 3 3 is the center of this. Got it? I am taking a 4 4 here, center, and family A and the Cypher Analytica aerial break from. So you will see. I'm getting the same. But if I run this, I'm making a family. And then I do that. Now I run this. Got it? And you see the different fonts I am getting. Getting? These are the symbols. So I make Windows fonts. A, what we are using the from family. This is a family. Examples, type family example, creating new mappings. So I'm making a new mappings, creating here. A family is equal to A. That is the, I have mentioned the color name also. You could write anything here. The syntax I have, for your understanding, I have written here. Got it?
Sir, what is the set of fonts family? Means Arial Black, Bookman Old Style, Comic.
You could use any this family I have created. So whenever I use the text a family name, then it will give me that color.
No, sir, I want a list of the Windows font. Okay.
Yes.
There are four. Okay. If I want to use another font, then how can we actually that list? Uh, Like a color or
We have only this.
uh, seven.
Here we have used this, no?
Yes, sir. There are 7 fonts.
Hmm. Margin and graph. You can control the margin using size using the following parameters. Margin MAR for the margin. Numerical vectors indicating the size. The bottom, left, top, and right, as I explained you. Bottom, left, top, and right. So what is the default parameter? 5442. 5442, but plus 1, plus 0.1. So 5.1, 4.1, 4.1, 2.1. Got it? This is the default parameter. 0.1 will add on in each element. This is the bottom, left, right, and bottom, left, top, and right. Okay. Now, axis and text. Many high-level plotting functions, plot, histogram, box plot, etc., allow you to include axis and text options as well as other graphical parameters. For example, I will explain you that. So I will show you later on this, the title. I will show this in the practical way. I will show you this. So we are attaching the empty cars data and the plot weight, mileage, and the main X label, Y label, PCH2, color blue. Both are the numeric variable. We are making a scatter plot. And I just run this first so you could see it better. 2 I am taking, so I am getting the triangle. If I take the 1, I will get the square, not the 0. 0 I will take, then I will get the square. Okay, so in this way I could change it. Now I want to use the text also. So the text, I will use the weight and the mileage, row names, empty cars, whatever the row names in the empty cars. I will take those row names here. The car model name I will get here. You will see. Get it. You could write on the right side. You could write on the bottom. You could write on the top. You could write on the left. So I will show you the option here. Position 4. Position 4 is right side. Position 3 will be the top. You see it is on top. You have to remove the first one, then you could run it. Then you will see it better. Not this, then this. It is on the top now. So you could change the position 1, 2, 3, 4. Color is red. So this is the size of the text. You could change the size 0.5, 0.2, whatever. Got it? Now the math annotation. You can add mathematically formulae to a graph using text-like rules. So plot math for the detail. I will just explain you with this graph. I am making 3 variables. One is variable is 1 to 10. Second is y is equal to x. These are the same, x and y are the same. And the z is 10 over x. 10 by 1, 10 by 2, 10 by 3, 10 by 4, 10 by 5, 10 by 10. I will run this, and these 3 I have created. I will show you. This is my x. This is my y. And this is my z. Got it? 10 divided by 1 would be 10. 10 divided by 2, 5. 10 divided by 3, 3.33. 10 divided by 4, 2.5. 10 divided by 5, 2. 10 divided by 6. 10 divided by 7. In this way I am getting. 10 divided by 10 is equal to 1. Now I am changing, I'm using the same parameter. I'm not changing the parameter because in the last time I have changed the parameter. So I have written this here. The plot X versus Y. So plot X versus Y. Type B, PCH21, color red. X on the Y axis, I don't want to write anything here. I don't want to write these labels.
Okay, that
Line
means
type 3,
and denote nothing, right?
nothing. X label I am not using. Y label I am not using. You will see here. I have no any tick here on the Y axis. Got it? On the X axis I have. Got it? Y axis I have xt, none. And the add x versus 1 by x. So lines I am making another lines I am going to add here. X and Z. Type B, PCH22. Color blue. Line type 2. You will see. Got it? Now I am making axis. It is the second axis. The first axis, second axis here. 8 equal to x. It is just like x. Or I could write the y also if you want. Labels x. Color x is red. Lace 2 I will tell you. What does it mean? Got it? Lace 2 I will show you. Lace 1. Then you will see the difference. Got the difference or not? Lace 3 I will do. Then you could see better. Not the lace 2. Lace 0 and 2. Lace 0 if I write. Just a moment, I remove this. I will do it again. This is the, in this way we are getting it. If I write the lace 2, you will see it will be, you see 1, 2, 3, 4, 5, 6, 7, 8, 9. Got it? Any doubt here? Have you got it or not? Otherwise I remove it and I will show you.
Got it, sir.
This is okay. Draw an axis on the right, in the right, with smaller text and ticks. So it is the axis 4 on the right and the 8 equal to z. Z values you will take whatever the z is here. Z, you know that. Labels round, z 2 digits, because we know that the z is like so many digits after decimal. So we take the 2 digits after decimal. Color axis blue. Lace 2. I explained you what is lace. Lex is 0 and 2 only. X dot axis 0.7 and the tick minus 0.01. So I will explain you this. Get this. This is the tick. This tick size we could reduce and increase through this. Okay. Minus means outside, plus means inside. If I remove the minus, you will see what happens. It is inside now. Got it? Outside is already there. We have created the last time. But if I remove this and I will create this again, you see it is inside now. So it is minus 1 I have written there. Minus I have taken. Okay. And again I do this. M text I have written. M text. y is equal to 1 by x. I will show you. It is not showing here. It is not showing here. It is showing here? No. Because we are using the line 3. If I use the line 1, you are getting here, I have got here. If I use the line 0, we are getting here. That is okay. I will just show you that. We have to run the whole thing. You see, y is equal to 1 by x. It is the 1 by x of y. That I have written there. Now the title, I will show you. This is the x values, x lab, y is equal to x. This is the x values. This is the x example of the with respect to y is equal to 1 by x. It is not the y, it is the z. It is the z. I have written wrong thing. No, y is equal to 1 by x, correct. Y is equal to 1 by x. Or z is equal to 10 by x, we could write here. That is not that reciprocal. Okay, that is the same thing. If I write the 1 by x, it's okay. So this is the thing, and the last we see here today, and that is the minor tick marks. So AB line will not do it. AB line is not beneficial here. Now I'll show you the box plot and the legend. We want to study about the legend. There is a legend. I have given the so many description about the legend, the location, title, legend, everything, and then you will go through it. You could see it. I am attaching this empty cars, and I am making this box plot, and I am using this legend. So first legend I have using this one. This is the vertical. Okay, horizontal false. It means I am getting the vertical. Horizontal true I am getting in this way 4 6 8. So this is a way of the legend we could show. Now somebody asked me today about the combining plot. We could combine the plots also. The various sort of plots we could combine. So there is a two-way MF row and MF call. So we use the MF row here and MF call also. So attach empty cast data. I am here attaching the empty cast data, and then I am taking the parameter MF row equal to 2 by 2, 2 by 2 plot, 1, 2, 3, 4 row wise MF row. If I'm taking the margin figure row wise. Okay. So that is, I have written here the complete of this MF row multiple figure row wise. Okay. So row wise multiple figure means if I taking the MF row 2 by 2, so I will get in this way. First figure, second figure, third figure, fourth figure. If I write the MF COL, MF column wise 2 by 2, so I will get 1, 2, 3, 4. Got it? Yes. So I just run this.
Yes, sir.
Now I am plotting one plot. That is the scatter plot, weight and mileage. The title is the scatter plot of weight and mileage. So I'm getting here first. The bar plot I will get on the right of this because the row wise I have taken the MF row. So I will get here. If I had taken the MF call, then I will get here. Got it? The difference with both. And I run this box plot, then histogram, then box plot of weight. Got it? Any doubt?
No, sir.
Now I make it default. And if I make it default and again I draw, then what will happen? I will get the original. So whatever your parameter you are setting on there, you make that P1 and then you again lost it. Run. Second time you run, you will get it. Okay. So here also I have created MF row 1 by 3. So you see 1 row, 3 column. Got it? And then 1 by 1 I have taken. We could default in this way also. 1 by 1 you will write. The next figure will be 1 by 1. And here I am attaching few more ways. Layout matrix, I am giving the matrix 1, 2, 3, 3, 2, 2 by row 2. This is the matrix 1, 2, 3, 3. So by row 2, 1, 2, 3, 3. Here would be a 1 figure and in the upper side would be a 2 figure. It is a 2 by 2 matrix. So first I lay out this and then I make a histogram. Second, and this is the 3, 3 I have taken. So I am getting this way. Single one. So there are so many other things.
So layout function doesn't get got
Layout function.
doesn't understand.
This layout.
Yes, sir.
Okay, I will explain you later on. Just I explain you that.
Three
Don't worry.
three.
This one.
Yes,
Okay.
sir. 3 3.
In the layout, what we are doing, we are taking a matrix. In the layout, I have mentioned here the matrix. Got it?
Yes, sir.
So we have to take the matrix. The matrix in what we are taking. We want to create 3 graphs. So first graph, second graph, third and third. I have repeated the third one. So in the third and in the fourth part, I will get the third graph itself. Got
Okay.
it?
Means third graph will repeat.
Will repeat. So repeat means it will only the whole space, it will take the one graph only.
Okay. Yes, sir. Yes.
So it is the 2 by 2 matrix basically. 2 by 2. 2 row and 2 column.
Sir, if I use matrix like means this this vector C 1 2 3 3. If I use C in the bracket parenthesis 1 2 3 and 2.
3 and 2.
Yes, sir.
So 1, 2, 3 and 2. You will get this one is this way, vertical way. Got it?
Nice, sir. Thank you, sir. Yes, sir. Got it. Thank you, sir.
You could do the so many combinations here. Okay. You could make here also this one also you could get the 1 1 1 3. Sorry, here if you write the 1 and here you write the 3, then you will get the here big. Got it?
Sir, please do 1 2 3 1.
1 2 3 1.
Yes, sir.
1 2 3 1. So 1 2 3 1. It will not work. It is a diagonal.
Okay, sir.
It is a diagonal. See, it will not work. Got it?
Yes, sir.
It will not work. It is a diagonal basically. If you write the 2, then it's okay. Na? Then it's okay. The diagonal, it will not work. Got it? So we have the so many options to combine the plots. Again, I am making one. The same I have taken, not the other one. I could adjust the height and the width. So I have given here the height and weight you want in which way. So it is the row 1 is 1 by 3 of the height of the row of 2. And the 2 is the column 1 by 4, the width of the column of 1. So I'm taking that in this way. So I will share this script. You could better understand these all things. in this way. Tomorrow we see the fine control on the figures and we finish it, and then we start the ggplot2. Okay, tomorrow we start the ggplot2, and it is finished almost, R basics. The fine control, if I explain you, then it will finish. The lattice we are not going to use. The fine control, I see how long it is. Fine control is a very small part. That is the last one. In the following example, two box plot are added to a scatter plot to create an enhanced graph. I will show you this one. So what I am doing, I am making a new figure, parameter for the figure C0, 0.8, 0, 0.8, new equal to true. So I will apply this, and then I am plotting one scatter plot. Okay, I remove this all now, then I can do it. This and this is scatter plot. So I have taken here some parameters. Okay, you see figure. So parameter 0, 0.8, 0.55 and 1, I am taking the new one now, and I will take the box plot. So I will get the box plot here, and I am taking for the third one. You'll see this, and I will write down the text. So it's the text here. It is the fine tuning, we could use it, but it is very tough to understand this all mathematics behind that, what we are using the parameter, how we are setting these values. So it will take very little time when you adjust it ups and downs, and then you could create a right one. Okay,
Sir, what is new?
new means on the same plot, the new figure may sustain, may draw on the same plot. That is the new is equal to true. Understand? Otherwise you draw this, if I don't run this, I will show you. If I don't run this, I will just run this, and then I run. Got it? When I use this new equal to true, then the other plot will be on the same page. Next plot will be on the same page. Got it?
Yes, sir.
And we have given the location for the next plot. Then again we have taken the new truths, because the third one we want also there.
This
Okay.
figure, so this figure parameter gives the location for the new graph.
Yes, yes. Okay.
Yes, sir.
I will show you once again. I remove this all. What happened? I am getting this. Then I am setting this parameter, and okay. If I change this position, you will see it will adjust. Got it?
Okay.
You see it is the point, there is a difference.
Yes, sir. 0 to 0.55.
So here it is 1. It is the 0. This 1, 2. 2 is 0.8, correct. And this is up to 1. I have taken 0.8. It should be the 0.8 now. I will try it. No changes there. Okay, so in this way you could change the parameter, whatever we have. So with this we have finished our R basics visualization. Tomorrow we see the ggplot2, which is the more impressive plots we will figure out there, and that's very easy than this. We don't have to remember this all things there.
Okay, sir.
But uh, but sir, this syntax, this script is very long. R
This
basic.
script is very long. There are so many other things I have written, and you could read and you could apply and uh, use and trial this thing. Then you could do it in a better way. In 15 days, 10 days, you could be perfect in this.
Can you please share yesterday's and today's code?
Yes, yes, I will share. I will share. I could not share the yesterday also, so I will share it. Okay.
Okay.
Okay. So thanks everyone. We wind up the session now.
Thank you, sir. Thank you for your time.
Okay. Thank you, Afsan. Thank you,
Thank you,
everybody.
sir.
Okay. Thanks everyone.